Hello students, welcome to Young Cubs Science Hub. Today I've got the chapter of electricity in physics for you. So children, what is electricity? Till today we did not talk about any particular definition in terms of electricity. All we knew was that there is something which passes through the walls or which activates our toys, and these things start moving or giving out some kind of energy. For example, the fan runs on electricity, the TV, the heater, radio, our ovens, and for that matter, even our even our toys, battery operated toys. Battery provides nothing but electricity. So today we are going to talk about electricity in more detail. We are going to understand the different terminologies associated with electricity. Children, did we know electricity had two forms? Okay, one was the static form and the other is the dynamic form or dynamic electricity, which is also known as current electricity commonly. Now, what's the difference between static electricity and current electricity or dynamic electricity? So, in static electricity, it's, as the name suggests, electricity or electrons. The word elect comes from the word electron. Okay, so electricity basically comes from the term electron. Okay, and we know in chemistry we've studied about the term electron. Yes, so electrons are nothing but the negatively charged particles or the subatomic particles which are negatively charged in an atom. Okay, if the negatively charged particles leaves the orbit or leaves the shell of a particular atom, the atom becomes positively charged, and if it gains electrons, it becomes the atom becomes negatively charged. So here this concept has been brought forward in physics. Okay, so however, coming back to static electricity, okay, it does not move. It is static. It is stationary. Okay, it is a build up of electrons. Just the electrons gather or accumulate together. Whereas in dynamic electricity, there is a flow. The electrons keep jumping or flowing like water or just around the loop. Okay, and this flow is nothing but it is called the current. Okay, it stays now in static electricity. As I said, it is static, it is stationary, it stays in one place until it jumps to another object. And how does the jumping happen? When you rub something against this object which is building up the static electricity. For example, our hair. Okay, our hair, the electrons keep building up. Okay, and then what happens if we take a ruler and we a scale, a plastic ruler, and we rigorously rub our hair with it? What happens is the electrons gets transferred. The electrons move or jump to the plastic ruler, and then and how do we come to know about this? Bring some bits of paper close to it, and the paper the paper bits cling to the particles or to the plastic ruler. All right, but then in dynamic electricity or current electricity, the electrons travel through a conductor. We've learned about conductors and insulators when we were young. Okay, a substance. What is a conductor? It is a substance that allows electrons to move easily through it, like in a wire. Okay, conductor is any substance where electrons from the outer shell jump easily out of their outer shell and move on, and that's how a flow is created. I will explain it more in detail, with the coming slides. All right, and there what happens? What about static electricity? The raising of hair. In the winters, okay, in the winters, normally we've seen hair standing on ends, or there's a machine which generates this electricity. If you've seen Mr. Bean series, one of the series has static electricity, and it generates static electricity, and the hair stand at the end. A very good example is when you wear your woolen clothes. That's when there's nothing but electrons are building on in the cloth, or in the wool, or in your sweater. Okay. And after rubbing a balloon against your hair, okay, the electrons get transferred to the balloon, and then the balloon can be stuck to the wall without any glue. Right? So this is nothing but building up of electrons. All right. And in dynamic electricity, the electrical current that powers appliances. So there is a push. These electrons are pushed across a circuit. I will explain. I will give you the proper definition of circuit as well. Okay, so the electrons are pushed, or the electrical current is pushed against the loop or the circuit, and that's how it powers appliances and machines, and that's how machines start working. The electrical current that comes from a battery, right? So what exactly happens? As I just spoke, electricity comes from the word electron. Here, if you see this, children, this is a copper electron. Electron, which is, the symbol is Cu. Okay, now check this. Okay, it has 29 protons. The first shell, this is the first shell which is closest to the nucleus, okay, will always carry 2 electrons, right? The another shell, okay, will carry 8. So the first one carries 2 electrons, the second one carries 8, and the third one carries how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 electrons. So 2 plus 8, 10. 10 plus 18, 28. And the last one has 1 electron. Now for this one tiny minuscule electron, there's an entire orbit. Okay, so this atom says, you know what, just for one, just because you're there, I can't attain stability. So if you just move on, or you just move out to another atom which is accepting electrons, I can become stable. So it happily wants to, this copper atom happily wants to give away this electron. So what happens is, now look here. Do you see this line that I've made? These 2 lines that I've made? Okay, one is short and one is long. The longer one is the positively charged, electrode. And the positively charged electrode is called the anode. And the shorter one is the negatively charged electrode, which is known as the cathode. Alright, so what happens is, this is basically together, these 2 electrodes form a battery. Sorry, it's not battery, it's a cell. Okay, cell is nothing but one pair or one cell, like the batteries, the cell that you put in, a complete cell that you put in your battery operated toys. So it's a cell. Lot of positive and negative these pairs, if laid side by side or are in one circuit, then it is known as a battery. Otherwise, an individual pair is known as a cell. Okay, so now what happens is this cell, okay, there's normally a switch. There's normally a switch. What does the switch do? The switch basically is nothing but where, that's the switch that I'm making. I'm making the symbol, children. Okay, we've done about these symbols. Okay, if the switch is open, nothing transfer, no electrons transfer. But if the switch is closed, okay, this entire thing forms a circuit. Okay, this is the switch. And once the circuit is formed, children, this negative electrode or the cathode gives a push. Okay, this negative electrode gives a push to this single electron. Okay, how does it give a push? This is negative, the electron is negative, so there's a repulsion force. So this wants to move out of the orbit and move to the other one. Now this one, okay, this one also has an electron, and there's another electron which is again come close to it. Again, two negatives, like poles repel. This one then wants to jump. So they are basically repelling each other, and that's how so many atoms, okay, they want to repel or they want to throw away their electron, and the electrons want to repel each other, and that's how the jump takes place throughout the circuit. And this jumping or flowing or moving of electrons is nothing but electricity flow or electricity is generated, or in terms this is current electricity or dynamic electricity. All right, children. Hope this much is understood. The jumping or flowing of these electrons from one atom to the other atom because of their repulsion, okay, is nothing but current electricity. Okay. Normally, children, it is the metals who readily want to throw away or give away their electrons from their outermost shell. Okay, and that's the reason why this electricity flows. So somebody is going to accept it, will keep it with themselves. They will not throw it out. They will keep it with themselves and be happy. I've got mine. I'm happy. So there will not be a flow of electrons in somebody, in some atom which is accepting electrons to complete its outer shell, and that's the reason why no electricity flows through these objects or these atoms. And these atoms or these elements are known as non-conductors or non-metals. Okay, they are non-conductors, or in other terms insulators. Simply they are not willing to transfer or push or throw away their electrons. Who's willing to throw away their electrons, or that's how the electrons flow around a circuit, around a loop, and electricity flows. So electricity flows, important point, current, electricity flows only through metals. Yes, children. Now, just drifting from the topic, we are doing physics. However, one thing that I would like to tell you is it's not, so this copper is a solid, correct? Okay, so electricity can flow through solids. Did you know electricity can flow through liquids as well? and that process is known as electrolysis. Electrolysis, where you create an electric circuit through a liquid. Okay. Let's talk about a few terminologies, as I had said, um, for this chapter to we better understand it. So, what is a source of electricity? Source of electricity is any type of fuel or a process or any phenomenon or any way, any particular way that creates an electric charge. Okay, that electric charge is generated out there. Okay, that could be any fuel, any object, any process. So in our case, in the chapter that we are studying today, it is going to be the cell. All right, children, let me just write it down for you. A source of electricity is, I'll just write source, is any type of fuel, process, or object that it could be any electricity is even generated in as a process, as a phenomenon, as a natural phenomena like lightning. So it is a source is any type of fuel, process, or no, okay, object or natural phenomena that creates electrical charge. How do you think we get the lightning? There is electric charge during thunderstorms and lightning. So they collide with each other, and that's how we have a spark or an entire lightning in the sky. So that's nothing but creating so it's a natural phenomena. All right, children. When we talk about flowing, something flowing in the circuit, what flows in the circuit? The negative charge, negative charge, or the negatively charged particles, negatively charged particles called electrons flow in a circuit. Circuit is nothing but an entire round loop. Okay, it keeps circulating. Circulating. What are the uses of this current electricity? It is used to run appliances like fans, ovens, air conditioners. I'll just write AC. Okay, AC. I'll just write AC, etc. All right, children. Well, that's all for today. Thank you and God bless you all.